Okay, so I want to welcome everyone to the first lecture of the semester, and I'm actually going to call that Introduction to Data Analysis. And the chapter from the textbook that you're actually going to read is chapter 0, okay? And of course, that is the textbook, okay? I think you guys can see that, right? Okay, so the outline for today's lecture is actually this. We're going to have introduction to the course. We're going to understand what we mean by models. Then I'm also going to walk you through what we mean by statistical model. Okay, so let us have an introduction to the course. Now, I'm going to tell you a little history. You know, there's a reason why you are taking this course. So this course is called, you know, Introduction to Data, it's called the Data Analysis. So which means we're going to be analyzing data, okay? But the question I want to, this is what I want to start from. Why do we need data? Why do we need to analyze data? What really happened? Okay, you know, and that is the reason why before you want to say you want to analyze data, you want to do something like that, there must be a reason for that. Let me tell you, there's what we call reality, okay? For those who have a trouble time understanding what I'm saying right now, I'm going to have a new share. And I need you guys to confirm if you guys are seeing my whiteboard. Can you guys see my whiteboard now?
Yeah, we can see it.
Okay, thank you so much. Now, this is what I'm talking about, reality, okay? Now, the question now is, what is reality? You know, the existence of things, okay, is independent of human knowledge. You know, if you look at the physical structure around us, if you look at, you know, happening around us, you know, if you look at the existence of the sky, the existence of whatever in the world, you know, that occur independently of human knowledge. And that is what we call reality, okay? But you know what? We as human beings, we actually want to understand the world around us. We want to understand our business environment. We want to understand political environment. We want to understand economic environment. We want to understand medical environment. We want to understand anything that exists. We want to understand so that that will enable us to know the way they work. And in a way, we're going to have a control, you know, about our environment. Because as human beings, we want to have control. Okay? And if we want to have control about our environment, then it means we actually need to model reality, okay? We need to model, okay? We need to model reality, okay? We need to model reality, okay? So if we want to model reality, what do we do? If we want to model reality, then in modeling reality, we need data. We need data, okay? We need data because I define, you know, in any scientific investigation, okay, data is very, very essential, okay? It means if I want to understand how things work, if I want to understand reality, then I need to collect data. If I want to understand the business environment, I need to collect business data. If I want to understand political environment, I need to collect political data. If I want to understand the medical environment, like for instance, we're in the middle of pandemic. Okay, you know, every country in the world, they are trying to figure out how they will be able to combat the COVID. Okay, so which means for them to be able to understand that, they need data. Okay, so in the process of modeling reality, okay, we need to collect data. We need data. Okay, and that was why I refer to data. You know, data data is, or let me just say data are essential. They are essential ingredients. Okay, they are essential ingredients. Ingredients, yeah, ingredients. The essential ingredients in any any scientific, investigation. Okay, so, and that was why I said we actually need data, okay, to be able to get things done. Let me see. I think that should be here, right? Kind of. Okay, so essential included in any scientific investigation is data. And you know what? When we collect data, we don't have information immediately. Something needs to be done to get the hidden information in the data. And that means we need to analyze, and that is what we call data analysis. Okay, so why do I need to analyze my data? I need to analyze my data because if I don't do that, I will not be able to get information. And you know what? To be able to understand the world, to be able to understand the environment that we find ourselves, we need to get information. Okay? We need information. Okay? And you know what? The information that we need is actually hidden in the data set. And the only way to get the information is to analyze the data set. And the purpose of this course is to be able to show you, is to be able to walk you through, statistical methodologies that we actually going to use in data analysis. Okay? And that is the essence of this course. And you know what? We did not only want to understand our environment, we also want to take decision, okay, about our environment, about things. And you know what? We don't want to take a decision that we're actually going to regret at the end of the day. And that is the reason why we need to go statistical. We need to go scientific. Okay? Any nation that does not pay attention to science, if care is not taken, that nation is not, that nation may cease to exist. Because what we need scientific knowledge, we need statistical knowledge to be able to understand situation around us. You understand what I mean? So that is the reason why you're going to take this course, data analysis. Now, some of you now see the reason why we need to analyze data. Okay, so I'm going to have a new share right now. I'm going to go back into the lecture material. If you have any question, or you say that you raise up your hand or you talk, then I'm going to now. And because of that, I'm actually going to define my data analysis as the process of systematically applying statistical techniques. The process of systematically applying statistical techniques, okay, to describe, to clean, to transform, and modeling data, okay, for the with the goal of discovering information. I'm going to say that again. Okay, data analysis is a process of systematically applying statistical techniques, because in this course you are actually going to be applying statistical techniques. Okay, why are you applying statistical technique? To describe your data, okay, to clean. Now when I say clean, there's something I'm going to do right now. Let me just I'm going to have a new share so that for those of you who may be having a trouble time understanding my accent, this is what I'm talking about. Can you guys see the definition right now? Can you confirm? If you see the definition that I'm projecting, oh, good, okay. Now take a look at that. I said the process of systematically applying statistical techniques to describe, because we're going to have data description. We're going to describe our data. We're going to inspect our data. That's what we call data inspection. Why are we inspecting our data? Because let me tell you this. Oh, can you guys confirm this right now? Can you see what I'm holding? This is a can, right? Can you guys see that? The can? Can you see the can?
Yep.
Can drink? Okay, thank you so much. Now, I can only drink the content in this can. I'm not gonna eat the can itself. I think you know that. Then this is the way data look like. This is a data set now. So what I need to do is to extract the information. The information I want to extract from here is just the liquid content that I want to drink. Okay? Then the can will be recycled, or maybe will be trash or recycled. I don't need that. Okay? So we do data cleaning. Okay? And that is what I'm talking about. The cleaning. We need to inspect, then we need to clean. Okay? And that's what we're going to do. Okay? And we're going to transform and model the data with the goal of discovering there's a hidden information in the data. Okay? We got hidden information in the data. And what do we want to use the hidden information to do? Because the hidden information will enable us to understand the world. Will enable us to understand our business environment. Will enable us to understand the political environment. Will enable us to understand whatever environment that we can talk about. And that is what we call data analysis. You don't need to be a statistician to apply data, to do analysis on data. Okay? So you can you can find yourself in any field and you apply data. You get data from any field. It's going to be the same technique that we're talking about. Okay, does that make sense? Okay, so I'm going to go back to this share or to the lecture material right now. Now, the next thing that I want to talk about right now is what are models? I told you the other time that we are in a world, we want to understand our environment, okay? And for us to be able to do that, then we need to use a model. And the question is, what is model? A model is a mathematical representation of reality. Okay? When I want to depict the reality using mathematical expression, that is what we call a model. Okay? That's exactly what we call a model. So which means in a way, we want to simplify reality. Okay? In the process of simplifying reality, there could be loss of a loss of generality. There could be information loss. Okay? And because of that, model is not the same as reality. Okay? And if model is not the same as reality, then it means we don't have a perfect control of the world. And that is the reason right now we got a pandemic in the world. Okay? And you can see that most of the countries in the world, they are still battling with this pandemic. And let me tell you something. They are using models, but you know what? Because model is not the same thing as reality. Model is an approximate reality, and that is the reason why George Box said, and I quote, all models are wrong, but some are useful. But you know what? We need to identify models that are useful. It is not all models that are useful. But you know what? We need to be able to understand like I said, if we want to understand the world, we need to get our data set, and after getting the data set, we need to have a model. Okay, and you know what? The state of the model and the state of the data set, they must you know they must match. Okay, the state of the model and the state of the data set, they have to be the same. So in a situation where the state of the model and the state of the data is they match, then it means you are actually using an appropriate model. And that is the reason why the essence of this course is to be able to walk you through, okay, if we have a business problem, if we have a psychological problem, or if we have a sociological problem, or we got a political problem, or we got economic problem, what is the appropriate statistical methodology that we're actually going to use? Because if you want to get things right, you got to use the best model, an appropriate model. But you know what? Even if you are using an appropriate model, model is not the same thing as reality. Okay? Even the perfect model will not give the exact picture of reality. Okay? And that is what we mean by saying model is not the same thing as reality. But model is going to do the job, by trying to, review on average the world, the reality, but not everything about reality. And I'm going to tell you why models are not the same thing as reality. Are you guys hearing me?
Yep.
Okay, just want to be sure if you guys are still hearing me. Okay, so like I said, the simplified reality will enable us to understand reality. If the reality is complex, in the actual sense, the reality is complex in nature. But you know what? If we really want to understand reality, if we really want to have the control of our environment, then we need to simplify, the complex reality. And an attempt to do that, when you try to simplify the complex reality, then it means you are actually using a model. Okay, and then with that, and that was why I said the suitable complexity of models can depend on the purpose. Okay, understanding or prediction. Okay, so whether a model is going to be complex or not, it depends on what you actually want to do with the model. So I'm actually going to walk you through, that is what we're going to be doing in this course. Okay, now I'm going to give you an examples of models right now. Can you guys confirm, has anyone seen something like this before? Have you guys heard about atom in physics or chemistry? Has anybody heard about that?
I have.
Oh, thank you so much. Okay, so atom is the smallest particle of an element that can take part in a chemical reaction. Okay, and you know what? We got a picture of an atom. When you are depicting a reality, something that exists is reality. Okay, and what we are trying to do is to model reality. Okay, so when I use a picture to depict an atom, this is what we have. Then it means I'm modeling. This is a model, because I'm depicting, I'm using picture to depict a reality, to depict something that exists. So this is an example of a model. Okay, now I'm going to show you another example of a model. This is another example of a model, because if you take a look at what I have right here, this was model, okay, to look like this. Okay, the engineer or whatever that that constructs this actually model reality, actually model something that can fly and stuff like that. So this is a model. It's an example of a model. Okay. Now, another example of a model, when you take a look at, I don't know whether you guys have been to faction parade before, where you're going to see some ladies or you're going to see some guys. They're going to put on some clothes, and all what they are trying to tell the world that, oh, this cloth looks so good, it's going to look good on you because it looks good on me. It's actually going to look good on you guys. That's a model. This is a picture of my wife right here, because she liked fashion. My wife liked fashion, trying to, stuff like that. That's a model. She's not a statistician. These people are not a statistician, but they are modeling. You don't need to be a statistician to be modeling. It now depends on different kind of, the kind of models that you actually want to do. Okay. Now, another example of a model is, take a look at that. This is a Google map. Can you see the Google map? This is depicting, using a picture, depicting locations. That's a model because that location exists. Then you are trying to depict that by a picture. That's a model. Does that make sense to everyone now? This is an example of a model. So I'm trying to show you example of a model, okay? Now, if you take a look at this is another example of a model. The one I've been showing you before, I've been showing you pictures, but this one is equations, okay? Model can appear in terms of equations, model can appear in terms of pictures and so on like that. So this is a Stokes, we call this Stokes equation. So this is a model, okay? Now, with that, I'm actually going to conclude that anything in life, anything that exists can be model, okay? Anything that exists can be model. And that is going to be my conclusion. And that is the reason why I got to cancel this. Somebody said my research system is complex and cannot be described in terms of any model. That's not true. That is not true at all. That is why I cross it, okay? Because anything in life that exists can be model, okay? And you know what? When you have a thought about how system works, then you are actually producing a model. I'm going to say that again. When you have a thought, oh, okay, this is the way system work, then you are already producing a model. Oh, this is the way it should look like. Oh, this is the way it should be. Then you are actually producing a model. Okay? So, but let me tell you something. In science, there's a particular language that we use that is generally acceptable, and that's a mathematical language. Okay, so we use mathematical language to express our thoughts, and that will now come in form of a model. Okay, it's more or less that, okay, we got a thought right now, and okay, we now want to put that into mathematical expression. Okay, when I put that into mathematical expression, then I'm talking about model. Okay, so that exactly. And you know what, mathematical modeling is not always easy or successful. Okay, they are, at times they are difficult. You got to do a lot before you'll be. I could remember when I was doing my PhD, I needed to derive a lot of equation before before I could get my results. But let me tell you something. If anything exists, if something exists, it can be modeled. If we don't get the solution to that right now, then it means that doesn't mean solution doesn't exist. Solution exists, only that it has not been discovered. Okay. Now, I'm going to walk you through different kind of models right now. Okay. I'm going to walk you through different kind of models right now. And I will first start with what I call a deterministic model. Okay? What do we mean by deterministic model? You know, when the future state of a system can be predicted from the initial states, that is deterministic in nature. Okay? The moment I have the initial values, the moment I know the initial state, given a particular initial state, I can actually predict the future state. That is deterministic in nature. I'm going to give you an example of a deterministic. When I say if a model that is deterministic is the one that does not involve randomness. It means that in that model, there is nothing like a random variation. Okay? And an example of such could be if you talk about pricing structure, okay? You could talk about map. You could talk about economic order quantity. Economic order quantity is an example of a deterministic model. Or you talk about linear programming model. So I'm giving you an example of a deterministic model right now. The linear programming model, the Google Maps, they are all deterministic in nature. The economic order quantity is also deterministic in nature. Okay? But let me tell you something. Most of things in reality are not deterministic. They are stochastic in nature. Why are they stochastic in nature? I'm going to tell you right now. There are two types of, in the world. We got two environments in the world. Okay? We got a certainty environment and we got uncertain. Okay, I'm going to have a share right now so that you're going to understand what I'm talking about. I'm going to have a share right now. Oh, give me 1 second. Can you guys see my whiteboard right now?
Yes.
Okay, thank you so much. So two types of environment. Generally in the world, we got two types of environments. Number one, there is certainty environment. We got the certainty environment and we got uncertainty environment. Now, what do we mean by certainty environment? In a certainty environment, there is only one state of nature. In a certainty environment, there is only one state of nature. When you say there is only one state of nature, then it means in that environment there is no variation. No variation, nothing to worry about. But you know what? That environment does not exist. Environment where you're going to have only one happenings. Environment where there is no changes. Environment where things remain the same. That environment does not exist. Because the essence of statistics, the essence of mathematics, the essence of manipulations that we do can only thrive, when there is variation. If there is no variation, there is nothing to worry about. It means things is going to be the same thing at different time. But you know what? We find ourselves in an uncertainty environment that I'm also going to call stochastic environment. And in this environment, there are so many state of nature. And that is the environment we find ourselves because different things happens in different days. There's a variation. And that is the reason why we are worried. That is why we are anxious about the future. And that is what we call an uncertainty environment. So in an uncertainty environment, we use stochastic model. We use a probabilistic model. And I'm going to show you right now. And that was the reason why I said, if you take a look at this, uh, what I have right here is a deterministic model. But right here is a stochastic model. What is the difference between a deterministic model and a stochastic model? In a deterministic model, if yi represent reality, then everything here is a model. So deterministic is trying to tell us that reality is the same thing as a model. But when you look at the stochastic model is trying to tell us that reality is not the same thing as model. There is going to be what we call uh, unexplained variation. Okay, there's always going to be unexplained variation. So what I'm projecting, what I'm touching right now is what we call unexplained variation. And you know what? No matter how we try, that part can never be zero. Okay, and this is an example of a stochastic model. But you know what? What we always want to achieve in research is to be able to minimize this error. How we can, and because of that, we got an assumption on the error. Okay, and the assumption is that the error follow normal distribution with mean zero and variance sigma squared. Now let me tell you something. Every stochastic model, every statistical model, every probabilistic model has assumption. Okay, and you know what? If there is assumption, there is limitation. Do you know the reason why we don't get things right at times? Do you know why scientists don't get things right at times? Do you know why researchers don't get things right at times? Do you know why when we do research and we make recommendation, do you know why our recommendation don't see the light of the day? Because we don't check whether assumptions in our models are violated or not. And that is the reason why at times we use model to take decision, but this decision, we're going to regret that at the end of the day. Because a model is as good as assumptions putting into a model. So if you really want to know whether your model is working, we actually need to investigate the assumptions underlying the model. So what I'm trying to tell the world right now is that stochastic model, in stochastic model, we have what we call unexplained variation, okay, which at times we can call a noise. Though we're going to try to minimize the noise. No, but no matter how we try, it can never be zero. Because if the noise equal to zero, stochastic model will become a deterministic model. Does that make sense now? And that's exactly what we're trying to say. Okay? But you know what? Yi here, if yi is reality, a plus bxi is going to be a model. And this is going to be unexplained variation. Therefore, the difference between reality and a model is the unexplained variation. I'm going to say that again. The difference between reality and a model is what we call unexplained variation. Okay? And that is the difference between that. And the unexplained variation, the assumption we put on that is that it should follow normal distribution. Okay? And that was the reason why we said, we are trying to quantify the role of chance by trying to consider stochastic model. Okay? Now, so with that, you really understand what we mean by statistical model. A statistical model is the same thing as a stochastic model. It's the same thing as a probabilistic model. Any model that have an error in it, what we call the unexplained variation in it, is a stochastic model. It's a statistical model. It's a probabilistic model. Because that model is also giving room for chance. And that is the reason why we call a statistical model is a probability distribution constructed to enable inferences. What do we call inference? Inference is a judgment. Okay. To enable inferences to be drawn or decision, made from the data. Don't forget, we actually want to make decision from our data. Okay, that's why we're analyzing that. But the kind of model that we're using, we should incorporate chance. We should incorporate random variation in it. Okay, so with that, we believe we actually, going to have the true picture of reality at the end of the day. Okay, that's exactly what we do. Okay, so because of that, I'm actually going to give you this. Take a look at that. The basic structure of a statistical model. When I talk about statistical model, I'm going to have a data equal model plus the error. Okay, my data equal to y, then my model is going to be f of x. And don't forget the model, like in a situation where I got two variables, maybe one is a response, the other one is going to be independent or the predictor variable. Then what I'm trying to say, for instance, is y is sales, and if x is advertising, okay, then I'm trying to say if I'm looking at the effect of advertising on sales, then there are other factors that may have effect on the sales, but their effect is negligible, or their effect is very small. And that is the reason why they don't really appear in the model. We're going to refer to that as a set of unexplained variation. Okay? So from there, I think I'm going to stop here today. I'm going to continue from here on Friday. Is there anyone who want to ask question or who need clarification on what I've been presenting? Is there anyone? Can you guys hear me?
Yep.
Okay, so is there anyone who need more clarification on what I've been presenting so far? Is there anyone? Okay, so okay. Did somebody raise up his hand? Oh, somebody say, "Oh, good." Okay. Okay, so I want to thank everyone for attending my lecture today, and I hope you guys enjoy my lecture today. Until Friday again, that I'm actually going to come your way. Please make sure you stay safe. And you know what? If there is anyone who need clarification, or check the canvas. My office hours is on the canvas. Okay, you can actually meet with me during my office hours, or you can actually send a message to me if you need any clarification. I also attend to students by mail as well. Uh, it's something I'm comfortable with because I actually want everyone to be in good standing at the end of the day, because I'm seeing society in you. So when you understand what I'm passing across, then you're going to be fine. Then the society as well is going to be fine in general. Okay, so you guys should should stay safe and do have a good day. So bye for now.
Thank you.
You're welcome.
Thank you.
You're welcome.
Have a great day.
And you too.
Thank you.
You're welcome.